Hello, good morning children. This is your Nagraj sir teaching mathematics for class 10. I welcome you all to today's online class 10. Today's my topic is arithmetic progression. Before we go to the content, before we go to the arithmetic progression, we have to first understand the meaning of the arithmetic progression. See, you all know that in the arithmetic progression, you all know the word arithmetic. Arithmetic means what? It is a branch of maths. You all studied in your previous class, it is a branch of maths. And it means what you studied in arithmetic? You studied about the numbers, study of numbers, or you deal with the number systems. Okay, progression. Progression is a new term for you. Progression means sequence. Sequence is a general term. It is a common term. Everywhere it is there in our daily life. Sequence means it is a events. Events means it may be anything. Even if you are coming from school to house to school is an event. So event, what events here in the arithmetic progression? Event means arrangement of numbers in order or rule. Order means what? According to some mathematical order, mathematical rule. See, what is a progression? Progression is a sequence. Progression is a sequence, and it is arrangement of numbers in order or rule. Order and rule both are same. Anyone will be followed in the sequence. You can frame your own sequence. For example, see, I have taken few examples here. Just observe these numbers: 1, 4, 9, 16, 25. What type of numbers are the children? Just observe this. These are perfect square numbers. What are they? These are perfect square numbers. How do we get these numbers? We get these numbers by squaring the natural numbers. What are natural numbers? Counting numbers are called natural numbers. 1 squared, 2 squared, 3 squared, 4 squared and 5 squared. 1, 2, 3, 4, 5 are the natural numbers. By squaring these numbers, squaring means raise the power by 2. 1 squared means what? 1 into 1. 1 into 1 means 1. 2 squared means what? 2 into 2. 2 2s are 4. 3 squared means what? 3 3s are 9. 4 squared means what? 4 4s are 16. 5 squared means what? 5 5s are 25. So if you continue like that, if there are n terms, there is no end for this. These are infinite number of terms. So therefore it is called n squared. See, for example, here 1, 4, 9, 16 and 25 is a sequence. These perfect square numbers are arranged according to some order. What is the order we followed here? The order, let me find out the order. See, here in this sequence, 1 is the first term denoted by T1, but in your textbook it is denoted as A1. No problem. Okay, second term 4 is denoted by T2. Third term by T3, fourth term by T4 and fifth term by T5 and so on. If there is n term, it is denoted by Tn. Tn means nth term of the sequence. Tn means what? Nth term of the sequence. Here T1, T2, T3, T4 and T5 are the terms of the sequence. Let me come to what is the order we followed in this? Look at here. But how we get the first term? By squaring 1. 1 square means 1. 2 square means 4. 3 square means 9. 4 square means 16. 5 square means 25. Suppose if there are n terms, that what is the nth, this one? N squared. Tn is equal to n squared is the general form of the sequence. What is the general form? General form is which is applicable to find out any required terms in the sequence. We can find out any required term. See, for example, if you want to find out the 12th term of the sequence, only I have written 5 terms here. If you want to find out the 12th term, what will be the 12th term? No need to write all the remaining terms. Just we can find out 12th term by just substitute n is equal to 12. T12 is equal to 12 square. This is the general form. See, T12 is equal to 12 square means 12 into 12. 12 into 12, that is equal to 144. 144 is the 12th term of the sequence. That is the use of the general form. See, this is the first example. After this, see, I have written one more example based on this only. Look at the terms. Observe these terms and observe the terms of the second sequence. See here, what is the first term? 1. What is the first term here? 2. What is second term here? 4. What is the second term here? 5. What is the third term? 9. What is the third term here? 10. What is the fourth term? 16. What is the fourth term here? 17. What is the fifth term here? 25. What is the fifth term here? 20. Just observe these two. So 1, 2, 4, 5, 9, 10, 16, 17, 25, 26. What difference you can find out from this? See, just observe this. Here the first term is written after by adding 1 to this. See, 1, 2, 4 plus 1 5, 9 plus 1 10, 16 plus 1 17, 25 plus 1 26. See, this is the sequence we followed. This is the order we followed here. How to find the order here? See, for example, how we got the first term in the first sequence? 1 squared, by squaring 1 we got 1. Okay, so 1 squared. What is the difference between this and this? 1 is added to this. 1 plus 1 is 2. 1 squared plus 1. See how we got second term? By squaring 2. Here how we got the second term here? 2 squared plus 1 is added. 2 squared plus 1, 2, 2s are 4 plus 1, 5. Look at the third term, 3 squared. 3 square means 9 here. How we got third term here? 3 square plus 1. 3 square plus 1 means 9 plus 1 is 10. How we got the fourth term here? By squaring 4. 4 squared is equal to 16. Here 4 squared plus 1. So 25th term 5 squared plus 1. See that you find the difference. 1 square plus 1, 2 square plus 1, 3 square plus 1, 4 square plus 1, 5 square plus 1. Why we have to do all this? Just to find out the order of the sequence. See here, 1 square plus 1, 2, 2 square plus 1 is 5, 3 square plus 1 is 9, 4 square is 16 plus 1 is 17, 5 square plus 1 26, 25 plus 1 is 24, 26, and here first term, second term, third term, fourth term and fifth term and so on. If you want to find the nth term, Tn is the nth term of the sequence. T1, T2, T3, T4, T5 are the terms of the sequence. And the Tn is the nth term of the sequence. What is the order here? The first term is written here 1 square plus 1, second term is written by 2 square plus 1, third term is written by 3 square plus 1, fourth term by 4 square plus 1, fifth term is 5 square plus. If there are n terms, what would be the last term? N square plus 1. Tn is equal to n square plus 1 is the general form of the sequence. Look at here, children. One more time I will explain how to find the order. See here, first term we got by 1 square plus 1, second term 2 squared by 1, third term by 3 square plus 1, fourth term by 4 square plus 1, fifth term by 5 squared plus 1. 5 square means 5 5s are 25 plus 1 is 26. So this is what the sequential order. So and here what will be the nth term? N square plus. If there are n terms, n square plus 1. Plus 1 plus 1 plus 1 is common in all the terms. Therefore, Tn is equal to n square plus 1 is the general form of the sequence. Again we will find out what is the use of the general form of the sequence. From the general form you can find out any required terms of the sequence. See, for example, if you want to find out the ninth term, put n is equal to 9. N is equal to 9 means Tn is equal to 9 square plus 1. 9 square means 81. 81 plus 1 is equal to 82. The ninth term is 82. No need to write all the terms. From the general form, you can find any required term. This is the second sequence. Okay, and I have written one more example for the third sequence based on the first one only. Look at observe the terms of the first sequence and the terms of the second sequence. Look at here, 1 is the first term and 0 is the first term. Here 4 is the first term, second term and 3 is the second term. 9 is the third term, 8 is the third term, 16 is the fourth term, 15 is the fourth term, 25 is the fifth term, 24 is the fourth term. If you observe this and this, what will be the difference? What is the difference? See, 1 previous term is written, 4 previous term is 3, 9 previous term is 8, 16th previous term is 15, 25 previous term is 24. Then how to find the order? Same here, first term T1, second term T2, third term T3, fourth term T4, fifth term T5. Similarly, the nth term is Tn. Tn is the nth term of the sequence. And now, what will be the order? How to find the order? Just observe this too. Observe this. How we got 1? How to get 0 here? First term is 1. First term is 0. How to get 1 and 1 from 0? By subtracting 1. 1 minus 1 is 0. Here second term is 4 and here second term is 3. How to get 3 second term here? By subtracting minus 1 from this. 4 minus 1 is 3. Third term is 9 and here 8. How to get the 9? 9 minus 1 is 8. 16 minus 1 is 15. 25 minus 1 is 24. Then how to find the order? Look at, we got here first term by 1 square, second term by 2 square, third by 3 square, 4 by 4 square and 5 by fifth term by 5 square. See, we are doing minus 1 common for all the terms. See, 1 squared minus 1. See, if you 1 squared, 1 minus 1 into 1, 1 minus 1 is 0. 2 squared, 2 2s are 4 minus 1 is 3. 3 squared, 3 3s are 9 minus 1 is 8. 4 squared, 4 16 minus 1 is 15. Fifth term 5 squared, 25 minus 1 is 24. See, 1 squared minus 1, 2 squared, first term is 1 squared minus 1, second term is 2 squared minus 1, third term is 3 squared minus 1, fourth term is 4 squared minus 1, fifth term is 5 squared minus 1. What will be the nth term? Here nth term is denoted by Tn. See, 1 squared minus 1, 2 squared minus 1, 3 squared minus 1, 4 squared minus 1, 5 squared minus 1. What will be the last term? N squared minus 1. So, Tn is equal to n squared minus 1 is the general form of the sequence. So, here how the problem should be given about this? They are not going to ask you to find out the order. They are going to give the problems like this. Look at the example. Find the first term, 4 terms of the sequence. Sequence is given. Sequence means it is the general form of the sequence is given. From the general form, you have to find out the first 4 terms. How to find? We will see first. Put n is equal to 1, 2, 3, 4. Take the sequence. Tn is equal to 2n plus 1. Tn is equal to 2n plus 1 is the general form of the sequence. From this general form, we have to find out the first 4 terms. First 4 terms means 1, 2, 3, 4. 1, 2, 3, 4. Look at here. I will put just substitute n is equal to 1 for first term, n is equal to 2 for second term, n is equal to 3 for the third term, and n is equal to 4 for the fourth term. And we will write the sequence. Put n is equal to 1. T1, wherever n is there, substitute n is equal to 1. What is the meaning of 2n? 2n means 2 into n. 2n means what? 2 into n plus 1. 2 into 1 plus 1. That is equal to 2 plus 1. 2 ones are 2. 2 plus 1 is equal to 3. T1 is equal to 3. The first term of the sequence is 3. Let me find out the second term. Put n equals to 2. Substitute n is equal to, wherever n is there, substitute n is equal to n is equal to n plus 1 is the sequence. In that put n equals to T2 equals 2 into 2 plus 1. You must know the meaning of this. 2n means 2 into 2. 2 2s are 4 plus 1 is equal to 5. Second term is 5. Second term is 5. Similarly, we will find out the third and fourth term. Put n equals 3. Tn equals 2 into 3 plus 1. 2 3s are 6 plus 1 is equal to 7. T7 3 is equal to 7. Third term is 7. What is the fourth term? Put n is equal to 4. T4 is equal to 2 into 4 plus 1. That is 2 4s are 8 plus 1 is equal to 9. T4 is equal to 9. Now the fourth term is 9. After finding all the 4 terms, let us write the sequence. What is the first term? 3. Second term is 5. Third term is 7. Fourth term is 9, and so on. Okay. Now I'll find out the 4 terms of the second sequence given. Tn is equal to 3n minus 1. Tn is equal to 3n minus 1. Like that you can take any sequence, any general form, and you can find out any required term, any number of terms also. Yes. Now again we have to find out 4 terms means n is equal to 1, 2, 3, 4 term. See, Tn is equal to, let us find the first term. Put n is equal to 1. Same here, 3n minus 1 means 3n means 3 into n minus 1. That is equal to, put n is equal to 1 in the, wherever n is there, put 3 ones are 1 here, 3 ones are 3 minus 1, 3 minus 1 is 2. Okay, put n is equal to 2. This is the first term of the sequence. Put n equals to T2 is equal to 3 into 2 minus 1. 6 minus 1 is equal to T2 is equal to 5. Second term is 5. Okay, put n equals 3 to get the third term. T3 is equal to 3 into 3 minus 1. 3 3s are 9 minus 1 is equal to 8. T3 is equal to 8. And put n is equal to 4. T4 is equal to 3 into 4 minus 1. 12 minus 1 is equal to 11. Fourth term is 11. Now let us write the sequence. What is the sequence we got? First term is 2. Second term is 5. Third term is 8. Fourth term is 11. Okay, and so on. Now we will see the differences between the first term and this one. Now I will rewrite all the sequences. Just observe, children, here. What you have to observe? Observe the difference between the two terms here. I will find out the differences. This is the first term, second term, third term, fourth term, and so on. Tn is the nth term, and the sequence is what? 3n minus 1. 3n minus 1 is the last term. Tn is the nth term or last term of the sequence. See, find out the first term and second term. 5 minus 2. T2 minus T1. T2 minus T1 is 5 minus 2 is equal to 3. Find out the difference between any two consecutive terms. Find out the difference between any two consecutive terms. 5 minus 2 is 3. 8 minus 5 is 3. 11 minus 8 is 3. And so on. Okay. Similarly, find out the differences in this sequence. Differences between the consecutive terms. You understand differences between the consecutive terms. Why we have to look at the consecutive term? Consecutive term is very much important. What is that consecutive terms? That defines the definition for the arithmetic progression. Definition for the arithmetic progression. What is the sequence we got? 3, 5, 7, 9. 3, 5, 7, 9. Look at the first term, second term, third term, fourth term, and so on. The nth term is Tn. What is the sequence given? 2n minus 1. Is the last term or nth term of the sequence. Look at the first term. Difference between any two consecutive terms. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. So this difference is constant, that is denoted by D. Here also this difference is common, that is denoted by D. See, these two I call it as an arithmetic progression. These two are arithmetic progression. Which two? Sorry. These two are arithmetic progression. AP. Shortly it is called as an arithmetic progression. But I will write, see, 1, 4, 9, 16, 25. What I took the examples now. After that you find out the difference here. 1, T1, T2, T3, T4, T5. Find the difference here. 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. 25 minus 16 is 9. Find out the difference here. And one more, after this I wrote one more. What is that? I took 2, 5, 10, 17, 25. Find out the difference here. First term, second term, third term, fourth term, fifth term. Find out the difference between any two consecutive terms. 5 minus 2 is 3. 10 minus 5 is 5. 17 minus 10 is 7. 25 minus 17 is 8. And I took one more. What is that? 0. After this 1, 0, 3, 8, 15, 24. Find out here also. First term, second term, third term, fourth term, fifth term. Okay. Find the difference here. 0, 3 minus 0 is 3. T2 minus T1. T2 is the next term to first term, T1. T2 is the next term, T2 is the next term to T1. T3 is the next term to T2. T4 is the next term to T3. Similarly, T5 is next term to T3. If you take like this, in the left to right, T1 and T2. T2 is the next term to this one. T1 is the previous term to T2. T2 is the previous term to T3. T3 is the previous term to T4. T4 is the previous term to T5. How to find the difference is T2 minus T1. T2 minus T1. 3 minus 0 is 3. 8 minus 3 is 5. 15 minus 8 is 7. 24 minus 15 is 9. What is my question now is, I am going to give you a question now. So I called these two are arithmetic progression. 2, 5, 8, 11. These are called, this is arithmetic progression. And 1, 3, 5, 7, and these two are arithmetic progression. These two sequences are arithmetic progression, but these three are not arithmetic progression. My question is, why these are not arithmetic progression, these are arithmetic. Let me see the definition of arithmetic progression and some definitions, general form, and also the common situation in our daily life in the next class.